All right, today we are going to do section 7.2 on multiplying and dividing radical expressions. So before we get started, we're going to do a bit of a review. So if I had the square root of 16 times the square root of 9, think about how you would solve that. You would say, okay, well, the square root of 16 is 4 times the square root of 9 is 3. So now you have 4 times 3, and that's 12. Okay, great. What if it was written square root of 16 times 9, like that? Well, in this case, you would probably multiply the 16 and the 9 first. Once you do that, you'll get 144. And now you take the square root of 144, and you get 12, just like you did before. So that leads us into the property which states that if the nth root of A and the nth root of B are real numbers, then the nth root of A times the nth root of B is equivalent to the nth root of A times B, okay? So using this with number examples, it's basically saying that if you have two radicals that you are multiplying together and they both are taking the same root of, so for example, they're both square root or they're both cubed root, they're both fourth root, whatever, then you are allowed to combine the two under one roof in the radical, and it's going to give you the exact same answer as if they were separate. So in our first example, suppose we were given the square root of 2 times the square root of 8. Well, if you tried to take the square roots of those separately, you wouldn't be able to do it. You wouldn't get whole numbers. But thanks to this property, we can say, well, wait a minute, that's the same thing as the square root of 2 times 8. And 2 times 8 is 16. And the square root of 16 is 4. So you get a whole number that way. Kind of cool. Okay, so I'm going to give you a new problem to do now. Once I write it, pause the video, try it on your own, and then see if you got it right. Pause. Okay, so here's the answer now. The cubed root of, let's put them under the same roof, -5 times 25. Okay, so that's the cubed root of -125. And the cubed root of -125 is -5. You might feel a little uncomfortable about that, saying, whoa, you can't take the cubed root of a negative number. Well, that's actually not true. You can't take the square root of a negative number, but it is true that if you multiplied -5 by itself 3 times, then you will get -125. Okay, so essentially that rule about taking the square root of a negative number goes out the window. If there's a 3, 5, 7, 9, any odd number outside of here, that rule doesn't work anymore. However, if this just was a square root right here, then it would be, it would have an I with it. It would be an imaginary number, okay? All right, so for C, once again, try this on your own. After I write it, go ahead and try it. And so this is going to be -2 times 8. And that's going to give us an imaginary number for I, okay? Not a real number. Not real. All right, so moving forward with a little bit of a trickier example. Suppose you were asked to simplify this. Cubed root of 54 x squared y to the third times cubed root of 5x cubed y to the 4th. All right. So how I'm going to start by doing this is just put everything under the same radical. I'm allowed to do that since it's both cubed root. If this was a 3 and this was a little 4 right here, then I would not be able to do that. I'd have to treat them separately. But since they're both 3's, I'm allowed to do that. So this is the cubed root of 54x squared y cubed times 5x cubed y to the 4th. Okay, let's clean that up a little bit. Let's combine all of our like terms. 54 times 5 is 270. X squared times x to the 3rd is x to the 5th. Y to the 3rd times y to the 4th is y to the 7th. Okay, that's a little bit nicer. So now, just like when we were reducing square roots and we looked for the biggest perfect squares under the radical, now we are looking for the biggest perfect cubes under the radical, okay? So it might be helpful to, when you're doing these sorts of problems with cubed roots, to go ahead and start by just listing some of the cubed roots on the side of your paper. So 1 cubed is 1, 2 cubed is 2 times 2 is 4 times 2 is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. Okay, and you can make that list as extensive as you'd like. So, biggest perfect square in 270. So what is the biggest one of these numbers that goes into 270? Well, that's 27. So we're going to split this 270 into 27 times 10. Okay, what is the biggest perfect cube in x to the 5th? That is x to the 3rd with an x squared left over. And the biggest perfect cube in y to the 7th is y to the 6th. Y to the 6th. And that is going to give us a y to the 1 left over, or just a y. Okay, so now at this point you are going to take the cubed root of everything that you can. So we can take the cubed root of 27, that is 3. You cannot take the cubed root of 10. You can take the cubed root of x cubed, that's just x. You can take the cubed root of y to the 6th, that is y squared. And there's an x squared and a y to the 1 left over, or just y. And there is your final answer. Okay? Okay. All right, I'm gonna give you a practice one now. B. 3 square root of 7 x to the 3rd times 2 square root of 21 x to the 3rd y squared. Okay, we're a little more comfortable with this one. It's square roots instead of cubed roots. Pause the video, try it for yourself, and here we go. So the first thing that I'm going to do is combine the outsides. 3 times 2 is 6. And combine the insides. So I'm just going to multiply those together right now. 7 times 21 is 147. X to the 3rd times x to the 3rd is x to the 6th. And then we have y squared. Okay. Biggest perfect square in 147. What could that be? Well, 3 squared is 9. Does that work? No. 4 squared is 16. Does that work? No. 5 squared is 25. 6 squared is 36. 7 squared is 49. Does that work? Oops. Oh, sure does. So that's 49 times 3. Okay, this is an even number, so it's going to come out nicely, as well as the y squared. X to the 6th is x to the third squared. You don't have to write it this way. This is just another way to think about it. Okay, so now we can take out all of our square roots. 6 times, when we take that out of the square root, we take the square root of 49, that's 7. 3 is going to stay under the radical since we cannot take the square root of that. Okay, this is going to be x to the third and y. And 6 times 7 is 42. Boom. Okay. All right, so if we just learn the multiplication property, what do you think the next property we're going to learn is? What do you think? What do you think? If you guessed division property, you were right. So the next property is the division property, which is essentially the same exact thing except you're using division. So if the nth root of A and the nth root of B are real numbers, fancy symbol means real numbers, and B is not 0, then it is always true that the nth root of A divided by the nth root of B is equal to the nth root of A divided by B. Okay, so you can go forwards and backwards with this. You can start separate and pull it together, or you could start together like that and separate them, whichever one you would like to do, whatever works for your problem. Okay, so let's see how this works with an example. The cubed root of 32 divided by the cubed root of -4. Okay, so thanks to our handy dandy property, we can combine those two as the cubed root of 32 over -4. 32 divided by 4 is 8. So this is the cubed root of -8. And the cubed root of -8 is -2. Boom, done. Okay, one to try on your own now is the cubed root of 162 x to the 5th over the cubed root of 3x squared yeah, 3x squared. Okay, give it a try. So this is going to equal the cubed root of 162 x to the 5th over 3x squared. And we can divide 162 and 3. Do not know that off the top of my head. That is 54. Okay, and if you'll remember the division property of exponents, which we learned back in Algebra 1, is if you are dividing two numbers that are the same base and have exponents, you can divide them by simply subtracting the exponents. Because think about it, if you have 5 x's on the top and 2 x's on the bottom, and you cancel like terms, you're left with 3 x's on the top. Okay? So the cubed root of 54, I don't believe has one. Nope. No, it does not have one. So we have to find the biggest perfect cube in 54. And that is going to be 27. 27 times 2 is 54. And x to the cubed is a perfect cube, so that's going to work. The cubed root of 27 is 3, because 3 times 3 is 9, times 3 is 27. And the cubed root of x cubed is x. And you have a leftover square root of 2. Done. Okay, the last thing we're going to talk about today is rationalizing. Rationalize the denominator. So if you're in my class, we kind of glossed over this a little bit. We're just going to go more in depth in it right now. So what rationalizing the denominator means is essentially that in math, you never, ever, ever want to have a radical on the denominator. So for example, if you were given square root of 2 over square root of 3, that is not considered simplified because there is a radical on the denominator on the bottom. So how you get rid of it is multiply the top and the bottom by that thing that is in the radical, because watch what happens when you do that. The top becomes square root of 6, the bottom becomes square root of 9, but square root of 9 is 3. Okay, now we do not have a radical in the denominator anymore, so it is rationalized. It is considered simplified. Okay, so rationalized denominator just means no radicals in denominator. All right, one more example for you to try is this one. Square root of x cubed divided by square root of 5xy. Give that a try. So how you do that is you multiply the top and the bottom by 5xy, square root of 5xy, excuse me. All right, so when you multiply a square root by itself, you can go through all the business of multiplying it together and then taking the square root, but it's always just going to come out to be exactly what it is, just without the radical, okay, just that. So, and then up here we have to do a little bit of work. So that becomes the square root of 5x to the 4th y. And of course, we want to simplify that as best as we can. We can't take anything with a 5 outside of the radical. We can take the square root of x to the 4th. That is x squared. And then the y we cannot touch either. So x squared with 5y in here and 5xy. Oh, and there's one more thing we can do now. There is an x on the top and the bottom. So that x will cancel with one of those x's, giving you x square root of 5y divided by 5y. Done. Okay, go try your homework.